All right, welcome everybody to the first episode of Brainstream. This is the BCI Guys podcast where we bring you cool information about brain-computer interfaces. I'm Colin Fausnaught. I'm here with Harrison Canning.
Hello, everyone. Yeah, so for this podcast, we really want this to be all things neurotechnology. But instead of reviewing papers or doing overly technical conversations, we really want to talk about what the future of this technology can look like and kind of construct that future. So we'll go into some ethical problems as well as project where we think the technology will go. And inside, like going along with that as well, we'll bring on some researchers, sci-fi authors, and other futurists just to think about where this technology might go and what we want to do with it.
Yeah, so this format's going to be a lot looser than our YouTube content. It's mostly going to be Harrison and I talking about fun topics, something that comes on our mind that we want to bring up and just discuss, and putting that out there for you guys. So like Harrison said, we're going to have a bunch of people on this that we're going to be interviewing in the future. We have some people lined up right now that we're super excited to talk to. But for now, we figured we do an introductory episode and get everybody sort of used to the format. So
Yeah.
so Harrison, let's talk about our backgrounds first. Do you want to go first?
Sure. Yeah, absolutely. So Colin and I are obviously both interested in neurotechnology and have been for a long time. My interest started in 2013 when I saw a video from Brown University utilizing the BrainGate system to help Kathy Hutchinson move a robotic arm to be able to feed herself, and that was just really exciting to me, and my mind opened up of what the possibilities of this technology could do. And I got really attached to this idea of making more human technology. And so what I mean by that is creating things that are more intuitive and work the ways that we think. So instead of looking at a 2D screen and typing, you could actually move around in a 3D interface and have a deeper connection with data. And so I kind of studied neuroscience, business, and computer science through high school. And then I went to the Rochester Institute of Technology, where Colin and I met to study neurotechnology through an individualized studies program. And then the two of us started a research group together, which I'll let Colin talk a little bit more about. And now we created the BCI Guys in 2020 as a way to create information that's educational and entertaining around neurotechnology to broaden the scope of the tech and introduce more people to it.
And to have something fun to do
Also
in
that.
pandemic,
Yeah,
which was
absolutely. Yeah,
quite a doozy. Yeah, so I'm
certainly
Colin.
was.
I'm Colin. As Harrison said, we met in 2018 at RIT. My interest, so I was actually a software engineering student at RIT, and the freshman year of my college experience, I learned about an open source company called OpenBCI. I went on to intern there in 2016, and I worked on some awesome experiments. Like moving things with your mind is really cool, and to have that experience of working with that in an actual company in New York at 21 years of age was an awesome experience to have. But that really got me interested in brain computer interfaces, and that led to me starting my own project called OpenBCI at the SSE, which was a Society of Software Engineers at RIT. And that led to Harrison and I meeting later with a connection from Dan Phillips. Shout out to Dan Phillips. He really made a big change in both of our lives by introducing us. So Harrison and I started a research group at RIT then, which was the first student-run research group in RIT's history, where we had, what was it, like 40 or 50 members at one point of undergraduate
Yeah.
students.
Yeah, so we got a generous grant from RIT based on a proposal that we had written. We started with like 6 people and thought that that's what it would end up being, but there was so much interest that by the end of the first year, we had 23 people holding research positions, so they had certain requirements, and then about 80 people in the overall organization. The rest of them were sort of like club members that would just come to learn. And so that also kind of spurred this media company for BCI Guys as well, because we noticed that people are really interested in this technology, but they just have to be introduced to it. So
Yeah, it's interesting. So we actually, RIT sent us to Dubai. We were very fortunate to go to a maker fair in Dubai. And at that maker fair, we had all these kids come up to us and they were like, oh, do you guys have a YouTube channel? And we were like, no, we don't have a YouTube channel. And they were like, oh, okay. And they just walked away. Um,
Now we do.
now we do. So that sort of was one of the inspirations that we had for starting the BCI guys. Clearly, this technology is very interesting, and clearly, people are super excited about this technology. It's just a matter of getting it in front of people, and we're
So
hoping
here
to
we are.
be, yeah, exactly. We're hoping to push that more, and hopefully try to reach the general public with some awesome projects that we have in the works, as well as some educational content. So we worked on the foundations of neurotechnology, which is our online course that we produced in conjunction with NTX, which is the neurotechnology, one of the biggest
Neurotech X.
neurotechnology, yeah, Neurotech X, sorry, which is one of the biggest neurotechnology groups in the world. They host conferences and stuff all the time. They have a huge active community, so we were very fortunate to work with them. Um, and yeah, I guess the final little tying the bow off on my background, I also taught a class for one semester at RIT in 2020 about brain computer interfacing. We're hoping to use some of the experience that I gained there of teaching how to work with these devices, and use that on our channel as well to hopefully make some introductory material for people who are just getting started, because that's one of the hardest things with brain computer interfaces, even EEGs and stuff, which are non-invasive. It's really hard to like where do you get started? There's so much information coming in from these devices. How do you plot that information? How do you filter that information? How do you use it to do meaningful things, like move robotic cars? Or we had a project where we moved a wheelchair. Like, how do you get from this large amount of data to doing useful stuff like that? So we're really excited for the future of BCI guys. We have a lot of projects in the works, but this is going to be more of a loose format where we just sort of talk about the topics and have people on to interview and that sort of thing.
Absolutely. So let's start out by introducing the topic that we're going to talk about through all of these, which is neurotechnology. So we have a more technical definition to start, which is a technology that records, stimulates, or works with the brain and nervous system to influence how researchers understand the brain and consciousness, supplement, engage, or monitor the nervous system, or allow a user to influence the functioning of a machine from brain function. So that kind of gives us an idea of the devices that can fall into this area. So Colin mentioned EEG, which is electrodes that are placed on the scalp that can record brain activity. Brain chips, or invasive implants like Elon Musk's Neuralink are, another type of neurotechnology. But there are also things that image the brain, like MRI, which everyone has probably heard of. And so that's sort of types of modern technologies that fit into that. But for the scope of this podcast, we really want to think about neurotechnology as a gateway to future human computer interaction. So we can really think about enhancing the brain and our relationship with technology through neurotechnology. So this can be things like potentially adding new senses, interacting with computers, robotics, exosuits, things like that, just by think, and even each other, just by thinking. And so that's kind of the tone that we want to set through this. But if you're looking for some more technical information as well, our YouTube channel does have breakdowns of current research.
Yeah, so our sort of our view for the future of how people interact with technology is, rather than having like a mouse and keyboard that you're using to type and move a mouse around on a screen, theoretically, with this technology, you could just put a headset on, right? And you could just use that headset to control everything on a screen, on a computer screen. Or even better, you could have some sort of augmented reality display, right? That uh, that essentially draws over your everyday um, tasks, right? So you could have
Mhm.
like a text message pop up on like glasses that you're wearing, right? And then you could respond to that text message just by thinking, oh, send this to, sort of like you talk to Siri right now, right? But instead of talking, you're thinking a command, and the artificial intelligence that lives there essentially does it. So there's a whole, that's just like the very tip of the iceberg when it comes to this sort of technology. There's a whole lot more you can do with this stuff, both invasively and non-invasively.
Yeah, and I think going off of that, the thing that really excites me about this technology is that it will open up like accessibility for higher levels of creativity, right? Because if you have software and technology that understands what your brain wants to do, then the learning curve of how to like use a piece of software goes down. So I think of the Adobe products and how powerful all of them are, like Illustrator and Photoshop, but how difficult it is, how many hours you have to invest to learn how to use these software. So what if, it could just be created like that? That's just a small example
Yeah.
as well. But
Or like, what if you have like in your head you have an image of something, right? Like you're an artist and you want to create something and you have an image of what you want
right.
it to be in your head. Currently we're limited as human beings by we have to physically move our arm in order to recreate that image, right? um, with this sort of technology, theoretically you could have that image appear in your head and then just have it appear on a computer screen in front of you. um, so the upside of this technology is huge, but there are some potential downsides as well. And one of the important parts of our mission as the BCI guys is to sort of talk about these social justice and morality issues that are related to brain computer interfacing and neurotechnology in general. And we want to get ahead of that topic now, before the technology is super invasive and super prevalent, because it's important to discuss these things before they're sort of out there in the world. So clearly, we have a huge vision for the future of neurotechnology. We think it can accomplish certain tasks that are impossible with modern technology and modern input devices right now. But with that sort of added functionality comes some risk, and some morality questions that we want to sort of get ahead of now, before this technology is prevalent, before everyone's using this technology. Um,
Yeah. I mean, I think of like Facebook and Twitter and but even just like advertising, modern advertising and how um the internet kind of works around that in data collection. And I think that we can all agree that there are some real dubious moral concerns that come out of a lot of that. And so
mm,
this technology, neurotechnology, is developing at a rapid rate. We're still, a ways away from everyone having a brain chip and walking around with that, but that's why we need to talk about this now, because part of our goal is to just make people more aware of it so that we can all come together and talk about what we want to happen, what is appropriate, and
mm,
what is not appropriate. And again, like that's kind of the theme of this podcast, creating the future of the brain, creating the future of technology interaction that we want, rather than one that becomes dystopian. Because Colin and I always say this could be the best technology of the next century and one of the best technologies that humanity has ever created. Or it could be one of the worst. So we want to steer away
yeah.
from the one of the worst side of things.
Well, I mean, we've seen in media situations where people are taken advantage of with brain computer interfaces. The fact that modern films are already sort of picking up on this as a risk should tell you that there's a lot of risk associated with this field. But once again, like Harrison was saying, it could be the best thing that's ever developed for interacting with technology. So it's probably going to be worth it. But we just want to get ahead of that discussion now and make sure that people that are developing these devices are doing them ethically correctly. So things like autonomy, right? Is your device going to affect an individual's ability to make their own decisions? With
Right.
this sort of technology, it's possible to influence the way that people think, like literally influence the way people think. I know we talk a lot about that with like social media right now, right? Where people are like, oh, Facebook's allowing people to be manipulated because of certain trackers or certain the way that they serve their content, right? But if you have a device implanted in your prefrontal cortex that can literally influence the way you think about things, how do we add safeguards there to protect people from malicious parties?
Yeah, absolutely. I do want to make one small caveat while we're running through this, which is that we are talking about the future of this technology and what
Right.
will be possible in the future. For all of the researchers and people that are working in the field that are getting angry at what we are saying right now, I want to stress that nobody has to worry about mind reading right now. That stuff isn't happening, and the field is almost entirely dedicated, at least in the research areas, to improving people's lives that have certain maladies like Parkinson's disease or are in a locked in state where they can't move or can't speak or both. So, like these devices are really improving people's lives and helping out in a lot of ways. So I don't want to get people too
Right.
scared about that now. But again, the goal of this podcast is to think about the future, think a couple decades down the line, and get ahead of some potential problems. So just keep in mind, Neurotech right now is helping out a lot of people, and we shouldn't go yelling at people that are doing that really important work.
Right. Yeah. Oh, yeah, for sure. Um, I mean, look at Kathy Hutchinson, like you were talking about earlier. Um, we have a device that's implanted in some individuals who can't move their bodies at all, that allow them to move robotic prosthetics or robotic arms in order to sort of regain some of this autonomy, that they lost because of their diseases. So right now, this technology is changing the lives for the better for a lot of people. And
Mm.
there's been recent studies that have come out, like the brain handwriting one, where you can literally think about handwriting something, and like imagine handwriting a letter or a sentence, and the brain gate system that's embedded in this individual can actually um, type it out for them on the screen. So you can imagine, for somebody who's in a quadriplegic state or somebody who's in a locked in state where they can't move their body at all, that's going to be revolutionary for that person. That's something that allows them to communicate much more efficiently than they previously were able to.
Absolutely, and that gets to that point of creating humanizing technology, because speech and movement are, I think, two things that are incredibly important to someone's mental health and just their feeling of being human. And so it's really really important, and I'm sure powerful, when someone who's unable to speak is enabled to start communicating again with this technology. But anyway, back to the main topics, which for this section around social justice issues and potential problems with the technology. Some of this stuff we can imagine ways that we've seen in sci-fi media where this stuff can become problematic. So on the other side of that autonomy coin, as Colin was talking about before, your thoughts could be influenced, and that's obviously something that we probably want to stray away from.
Yeah.
Although, like, what if you could influence someone not to engage in addictive behavior if they're consenting to that? So these are always kind of gray areas.
Right.
Um,
There's actually been studies done. Sorry to interject, but there's actually been
Please.
studies done where they've been able to stimulate the prefrontal cortex in a certain way to increase likelihood of risk-taking behavior. And this is
Mm.
a study that we covered in our Foundations for Neurotechnology course. Um, but essentially, they were able to influence um, participants into taking more risky stances with certain stimulatory devices. I'm not exactly sure. I think it was TMS, but I could be wrong about that. So, but there is scientific precedence for this sort of manipulation of autonomy, manipulation of thoughts. So it's why we wanted to bring it up here and talk about it a little bit.
Yeah. And the next kind of big thing, so we have a couple directions that we can go with this. So one of them is abuse. So that's kind of what we're talking about right now, in negatively influencing someone's mental processes or peering in on someone's private thoughts. Like, we want to avoid those things, obviously. And then there are the other things that depend on how the device is constructed, but could you overload the brain and actually cause damage? And like, what would happen if a bad actor was able to get access to the brain chip? And now there are ways that you could design design the actual hardware to really minimize the amount of damage that can be created or the data that can be picked up. So those are the kinds of things that you'd want to be able to do. You can limit the areas that you're physically putting electrodes in so that you can only access so much information, right? So we have that kind of aspect of things. And then we have the other aspect, which are the social issues that can arise from this. The most obvious one is that, if these interfaces do what we're talking about, what we think that they'll be able to do, people that have these interfaces will have a tremendous advantage. And I think that that advantage isn't great. What it'll be able to do for people in humanity in terms of increasing their capabilities is fantastic, but there's going to be an inequality gap between the people that can afford to buy these devices and are willing to buy these devices and the people who cannot afford or are unwilling to get these devices. And so if you have a class of people that's able to afford them and other people that can't, that class will continue to uh, you know have more value to a job market, or will innately have more value to a job market, and that will be problematic. So it's
Yeah.
something that we have to really consciously think about ahead of time, and how are we going to roll out these devices in a way that is equitable.
Yeah, it's similar to mobile devices now, right? Or laptops today. If you don't have access to a cell phone, like a modern smartphone, you're going to have certain limitations on your ability to find a job, or your ability to be exposed to um, certain avenues of finding a job. So, for example, like maybe with a smartphone, you have a LinkedIn app that you can look through and you can apply to jobs and stuff like that. If you didn't have a means of accessing the internet with a smartphone or a laptop or a computer, then you're inherently going to be limited because you don't have access to this life-changing technology that everyone's using. Same thing with brain computer interfaces and neurotechnology in the future. What if you had a device that could improve your cognition to a point where you have perfect memory, right? Well, clearly you're going to be a better candidate than somebody who doesn't have perfect memory, for a job, right?
Or in schooling and stuff too, right? Like you wouldn't fail a test.
Yeah,
you know,
exactly.
it's
So how do we make sure that everyone has equal access to this stuff, as well as creating ways for people to essentially buy their way into better versions of the technology? I mean, it's the same thing with smartphones, right? Like you can spend $300 on a phone from 5 years ago and sort of have all that basic access, but you're not going to have all the bells and whistles that somebody who just bought the $1,500 new iPhone or whatever.
Yeah. And so while this is a problem, we have to think and get ahead of regulation and just think about how we want this stuff to be created. A lot of people have a valid opinion of, okay, well, maybe we shouldn't produce this technology, or we should put constraints around outside of a medical environment. You shouldn't be able to use this technology. And that is somewhat of a solution, I suppose. But one, I don't think that it's really practical, because there will always be someone else that produces it. If it were banned in our country, the United States, then it's likely that another country would not ban it, and then you have sort of this arms race of brain power, which is really scary to think about. And the other thing too is we do think that this will be a really important advancement for human evolution almost. And so I think, as is true with Colin's smartphone example, I don't think that we would have advocated for not having smartphones, even though the first iPhone came out in 2007, and it has taken a lot longer for everyone to, or almost everyone to get a smartphone. But that did end up working out. And I think it's similar to the COVID-19 vaccine, where there is a huge inequity, unfortunately, in how that vaccine is distributed. The United States has basically more than we can even get into people's arms, and many countries, it will be years before they can reach a herd immunity level. But I don't think that that means that we shouldn't have produced the vaccine. And so while neurotechnology might be a more exaggerated version of smartphone creation, or something like a vaccine, I don't think that those inequities should stop us from doing it at all. I think we need to have a plan ahead of time of how to keep people from falling too far behind and help them catch up.
Right. Yeah, have some of that sort of thought process built into the manufacturing just from the get-go. And sort of on that level of talking about the actual manufacturing of these devices, there's a lot of talk right now about right to repair in the United States. Um, and I think that that's going to be important for these sort of devices, both
Which
from
is,
a
explain what right to repair
right.
is
So right to
briefly.
repair is what it sounds like. You have the right to repair devices that you own, right? So a lot of bigger corporations have been fighting against the right to repair because they want to have basically a monopoly on the parts that are used in their devices. So, for example, Apple wouldn't be happy if you took your iPhone to a third party person to repair your phone. They would
Or
rather
fixed it
have you
yourself, right?
right. They would rather have you come in um,
To
and
their store.
to their
Yeah.
store, yeah, and to basically overcharge you for the repairs that your phone needs. Um, how does that then scale to brain computer interfacing? How does that scale to neurotechnology? Um, are people going to be able to repair their own devices? If it's implanted in your head, do we want a bunch of people out there that are doing brain surgery on themselves essentially?
Yeah.
Or would we have certain spots where people could go to get a touch up on their device? It's a good. It's a
Yeah.
question that's a difficult thing to answer right now because we don't really have the technology yet, so we're not really sure, um, what sort of repairs would need to be done. Um, you
Right.
know,
Yeah, and it kind of just goes into like we would need to sort of require some level of standardization, because I'm thinking maybe I get a Neuralink implant and oh, it's great for 5 years, but what happens if Neuralink goes out of business,
mm,
or like, or if there's something wrong with the device or I want to get an upgrade or something, do I have to go to Neuralink to do that? Am I sort of, is my brain now bound to this company in a
mm,
way that, you know, is not true of iPhones? I mean, or Androids. Like Apple might try to keep you in place with their iMessage, but you ultimately can get over that pain and go to
right.
Android
Well, look
in
at
a
the
way that you might
dongle.
not be able to without.
Look at the dongle thing that happened too, where they changed the charging ports for things. So what if you had a charging port that was in your forehead, and they decided to change the charging port, right? Like,
Right.
well, suddenly I can't plug in the thing that's embedded in my skull. So like what like so questions like this are important to bring up now. Topics like this rather are important to bring up now because we want to make sure that we're thinking long term with these devices, no matter what the device is. Even if you get a device now and you have it in your head for 20 years, you've still had that in your head for 20 years. It should be able to scale with the technology that's available at the time.
Which is a neural engineering problem that we have to think about in
Yeah.
terms of like how can we make the hardware modular in a way where, okay, you want an upgrade, we can add more electrodes but the old ones aren't useless, or obviously if we're talking about a non-invasive device, that's not as much of a problem, but how can we design devices that are upgradable? Yeah.
Yeah. Here's an interesting one too that we have. What about repossession? So what if you have an implanted brain computer interface and you have a payment plan set up for it and you've been missing all your payments, right? Is somebody gonna come kick your door down and rip something out of your skull because you didn't
Oh God, that's where we're going with that, huh? Okay.
because you didn't make your payment on time, you know? Um,
Well, hopefully we'd find a better model than that. Jeez, but yeah, that's a good point. Subscription service for neural implant would be terrible. What if you have um, a device that you need for medical purposes? Maybe you're curing some sort of a mental illness, and it's under a subscription model where, oh, you missed your payment, they shut it off, or oh, sorry, this healthcare company has stopped covering it. Good luck. They cover a different device now. Like we have to fix these issues, and so right now we're just proposing these questions because we want to all think about it. We will try to eventually over time bring on experts that we can actually try to think of some answers to these questions. There are no perfect answers, of course, but in hearing from people listening and others, we will try to work towards some solutions that we all are okay with to avoid these things. But right now we're just gonna scare and excite everybody a little bit with some of these
Hey, one more
questions.
scary thought before we move on from this
Thank
topic.
God. Yeah, one scary thought in my head is you with a lightning cable coming out of your head now that you said that. But go ahead. What's your last scary
That
thought?
sounds like a thumbnail.
Oh
Um,
no, I'll get on it.
what about advertisements? So one of the issues that we've seen prevalent in social media are ads being served basically everywhere, right? What if a company could beam an ad directly into your brain, with these devices that we're wearing? Um, could that create problems like psychologically with somebody where they're always thinking like they're forced to always think about a certain product? Um,
Yeah.
or is there a way that we could build these devices to be ad resistant so that that's impossible for people to serve advertisements and stuff?
Yeah, I mean, I don't know. I wouldn't mind if I saw a billboard and was able to taste Cocoa Puffs from looking at a
That would be
billboard,
cool.
but
That would definitely be cool. Or
no, but
that's a good solution though, actually, is you're externalizing it, right? So you're saying, oh, you see an advertisement and then that is what triggers the advertisement thing in your implant, right? Like that's a good way to combat that potentially is that you can only react to certain, like your brain computer interface only reacts to things that you physically see in the real world.
yeah, I mean, I was kind of joking with that, but actually that brings up an interesting thing. So you know how like with Snapchat or other like AR things, you can scan different devices and a little pop-up comes up and you can choose to do it. I think that would be okay, and we could expand beyond ads to things in your environment where you could look at something and then consciously be interested in learning more, be like, oh, I'm interested in that, and then like you get a pop-up in your vision. I don't know, it's a little scary, but like
That'd be cool.
there's some sort of like overlay in your vision that allows you again consciously to interact with this more. Like that might be an okay way around it. I'm still a little scared of having the advertisement conversation around that, but like that might be a way. I think one of the biggest things with all of this is we have to find a way to make sure that the person is in control all of the time. So I'd like to think of it, use vision as an example. I can close my eyes and choose not to see, right? And I can open my eyes, and that's a conscious decision that I'm making to look around. And so if we can provide a gateway that can't be messed with, that is similar to vision, where I can intentionally block things out or open that gateway, then I think that's a good solution for all of this stuff,
Yeah.
because it gets back to that autonomy point. And I think that that's the most important thing that we can do when we're talking about this stuff.
Yeah.
Um,
A
and,
simple on and off switch, even,
yeah,
embedded in your
absolutely.
forehead.
Right under the lightning cable port. Fantastic. We're going to look weird. People of the future. I think it's funny to try to think about what a future human will look like, right? Because we have like all these artist interpretations that are over exaggerated of the person hunched over and just like gross from not going outside for 6 weeks or whatever it is, being in front of their computer. But I do think it'll be interesting how, like, what that looks like, because we're already seeing a lot of willingness for people to change their bodies and modify their appearance. I mean, tattoos have been around forever, and there are all sorts of body modifications that people have willingly taken in and that come in and out of science, right? And there's a growing movement of biohacking, where people inject all of these things into their bodies and modify their appearance. Whether, I think the most common one is an RFID chip, like in your palm or wherever, so that you can like tap your palm to pay or unlock your car or whatever it is. I've seen people implant like orbs into themselves that they are like can sync up to their smartphone and charge from your bio data. Like that's freaking wild. And so there's a lot of stuff like that, and I think it's interesting. I hope that there wouldn't just be like a big red switch on your forehead, but it'll be interesting to see what the future of fashion looks like, and how society, and to what extent society embraces this like technology future. Like, does it look like
Right.
cyberpunk stuff, or is it more subtle and we just look like we do now and you can't tell that you're wearing a brain computer interface? Or does it become a status symbol of like, look, I've got this shiny Apple brain
Yeah.
computer interface or whatever it
Does it
is?
become the next cool thing to chop your arm off and get a robotic arm there instead? Like,
Oh
uh,
god.
who
Yeah.
knows? I mean, we're saying, oh God, right now, but like,
Right.
um, it
Right.
could be similar to getting a tattoo in the future. Like, I mean, it makes sense, right? If you have an arm that does everything that your arm does, it's just stronger and can interface with modern technology, or the future technology, I guess.
Right.
um, Maybe it makes sense for somebody in the 22nd century to just chop their arm off, get a new one.
Sure. Yeah, which is like a weird thought. But yeah, I mean, it's something that could happen, and I think we're advancing what prosthetics can do for people who have lost their arms. Now, it's not anywhere near right now what uh, a normal arm would be, but I think we're getting there. On the tattoo thing, I just thought of something. They have these tattoos that have EEG, so brain
Hmm.
sensing, or EMG, muscle sensing electrodes built into them. And
Yeah.
so like that's really cool. And is that a potential interface that we have, where we have these tattoos around our body that can send this muscle information back, and can we use that for something? And
And
that's
what
another like aesthetic modification, but is functional.
health problems would be related to having conductive material embedded under your skin as well? I don't know if that any studies have been done on that or not, but I don't know if you knew this or not, but tattoo. So I have a tattoo, and tattoos actually, the ink from them gets broken down by your body over a long period of time, and it goes through your lymphatic system, and it goes out, it's excreted out from your lymphatic system, and that's why tattoos fade over long periods of time. So would that sort of thing happen with conductive material? Um, would things fade over time? Would you have to get touch ups? Would that have any negative effects on your biology? Um, and these are all questions that future humans are definitely going to have to tackle, because this stuff's going to become really common. I mean, I think brain computer interfaces are going to be as common as the smartphone someday, or the touchscreen. someday. It's going to be a no brainer. Pardon the pun, but
How
everyone's
many
going to have
times are
one.
we going to say that on this podcast? Like literally, X thing will be a no-brainer, comma, part of the pun. Like how many times are we going
That's
to
a
say
shirt right there. That's a no brainer. Pardon the pun.
that? I'll get on it after this.
Anyway, that opens an interesting question. When we're talking about cyborgs, would you consider, Harrison, modern people to already be cyborgs?
I would. I mean, there are multiple schools of thought on this that fall on a spectrum where some people believe that anytime a human is using a tool, that they are, in a sense, a cyborg. And there's neuroscientific basis for this, where humans, when you hold a tool, when you use a tool, it sort of becomes a part of your mental model. The simplified example is you can think of a hammer, and you're able to hit that nail because your brain can track and almost get proprioceptive information from where that hammer is, even though it's imagined, unlike the information coming from your hand and stuff, right? And so that's like on one extreme, and the other extreme is Hollywood, which is showing us like a Luke Skywalker arm or a Terminator type thing. For me, I pay attention to the first part of the word cyber, to say that it has to be some sort of electronic device, but I would say that it doesn't necessarily have to be connected to you, like a smartphone. You are, the way you think changes when you have a smartphone. The way you
Right.
engage in activities changes. I'm now storing information in a smartphone. My ability to remember like directions is terrible now that I have a GPS, but I also don't need that because I have a GPS, and it's just better. And so I offload mental tasks onto that. So I would say that we are definitely cyborgs right now, and the stretch to just moving that information directly into your brain doesn't seem like like that big of a leap for me. What are
Right.
your thoughts on that?
Yeah, no, I totally agree. I think that people are going to be more open to using in the future. People are going to be more open to using brain computer interfaces, even invasive ones, specifically because of what you just said. Of like, we're already doing it. We're already using the internet constantly to store information, to look up information that we may have forgot, to give us directions to a place. There's so many different mental tasks that we had to used to literally I mean, we used to when I was a kid, I had to remember people's phone numbers, like literally had to remember
Mm-hmm.
what their phone number was, and then you know put it
What a
onto.
concept.
Yeah, it's crazy, right? But now we have devices that remember all that stuff for us. We're definitely going to see this melding of humanity with technology in a more dramatic way, for sure, than it is currently. But it's I think the fact that we're marching towards that already, I mean, it's going to happen inevitably.
Yeah, and this sort of a thing, I mean, it all comes back to a question of value, right? Brain computer interfaces today don't provide much value to the
Right.
average person, because is it worth getting a brain implant to type 18 words per minute with my mind? Of course not. I can type faster with my thumbs.
And we're
And
limited too with the current knowledge of the brain, right? Like we're not
right,
exactly sure where certain areas of the brain that we'd like to target in the future, like what exactly they do, and we don't
for
know.
learning and memory, yeah,
Yeah, we don't
specifically.
know with extreme detail what we would need to know in order to create some of these futuristic devices that we're talking about.
Yeah, absolutely. But, as that value increases, it'll become harder and harder, like the smartphone, to not use them. And so I think that we definitely will see that transition, and people will warm up to them. But yeah, and I think that as we see with the cyborg movement, it won't just be the brain; it'll be parts of the body as well. If we can enhance different things, if we can make ourselves more valuable, which I know that sounds weird talking about a human and value, but maybe allowing our bodies to be more valuable to us is a better way to think about that. We get into a lot of data collection. And so we already think of, our smartphones and our technology as just kind of always streaming data about us, but now it's another level. It's the inner workings of our nervous system. And so how do we, which on one hand, just like, smartphone data can help you type better by giving you suggestions or give you content that you want to listen to, and it can be a good thing. It can also be a negative thing. And so as we exponentially increase the amount of data collected on us, how do we, like, who owns that data? Does Apple, is my data on a server somewhere that Apple has, and I have to just trust that they have the right security protocols in place? Or, what are the rules and laws around that protect me and my data that's collected from my body?
Yeah, and you bring up an interesting point there too with autocorrect. Artificial intelligence. How does that, you know, play into this? Is there going to be a point where we have super intelligent artificial intelligences who are able to interface with these brain computer interfaces? Would that be a positive thing for humanity? Would that be a negative thing? Um, could an AI control you with an implanted brain computer interface, or would you sort of meld your mind with an AI in order to increase cognition? Um, there's a lot of questions with the cyborgian future, um, as Harrison likes to say, that we really won't know the answer to until it's already been sort of experimented on, and the technology moves in that direction anyway.
Yeah, absolutely. And all of these things, again, it's very interesting to think of the social implications of all of this stuff. So we're getting this data collected, we're changing ourselves, back to that cyborg conversation, where we're changing ourselves, and then what does that mean for our sense of identities with ourselves? And is there a line to this? Are we changing our consciousness? Like, what is like,
Where's the cutoff?
where does all of this stuff go? And
Yeah.
then there are, we history repeats itself, the common saying, and there are very concerning events of our past that can inform or warn us about what the future could look like. So again, with all of these human enhancements, we're, creating class divides, and will that create ostracism for certain people? So in the United States, there was something called the eugenics movement, which was basically on the aspect of, yeah, go ahead.
They would measure people's skulls and stuff and try to find um, physical representations of what makes people different in terms of race, and try to use that in order to create legislation that would be like, they would do things like put mentally handicapped people in homes and stuff because
Yeah.
they didn't have a certain IQ, or people, they attempted to make it so that people who didn't meet certain criteria couldn't reproduce, and
Mm-hmm.
the idea of that being, we're trying to make humanity better genetically, but where do you draw the line? um, and honestly, people aren't that simple. It's not as simple as saying, oh, he has an IQ lower than a certain amount, he shouldn't be in the gene pool, because IQ is not a definitive representation of intelligence. It's a pretty flawed. It's not completely flawed, but it's a pretty flawed system in terms of assessing general intelligence and social intelligence and that sort of thing. Um, so another aspect of these devices is enhancing your ability to think, right? So the ability to remember things, the ability to make decisions quickly, the ability to make unique decisions that um, are adding value to whatever you're working on, right? So coming up with a unique solution to a problem, that sort of thing. These sort of devices theoretically, and have already shown in some studies, the ability to help decision making processes, help improve cognitive abilities of the individuals wearing them. So, what sort of applications do we have with that sort of device? Well, there's military applications, right? You could theoretically have somebody who's an enhanced individual who makes the best tactical decision for your army. There's technological or tech company sort of decisions. That sort of talks back to that inequity thing that we were talking about earlier, where maybe we have somebody who has one of these super advanced devices that improves his ability to come up with new ideas for a tech company. And suddenly, he's running the tech company because he's so much quicker and so much smarter than everybody else around him who doesn't have that device. Um, so, you know, there is some scientific precedence to this topic already. As I talked about earlier, there is some studies that have shown that um, with certain stimulatory devices, notably transcranial magnetic stimulation, you're actually able to increase recollection of memories, as well as increase the encoding of memories. Um, so now that there's sort of a scientific precedence for this, where do we go from here? How is this going to affect the future of humanity?
Yeah, absolutely. I don't have anything to add to that, but yeah. I do think that the concern is very real, but the pace of that is sometimes overstated. So we have this idea of in AI, and I think that it's transferable to neurotechnology as well, where we create a hyper intelligent AI that creates a more intelligent AI that creates a more intelligent AI, and it can do that very rapidly. I think, the progress is rapid on a large scale of in terms of decades of what neurotechnology is able to do, but it's not going to be like there is this device that goes out, that is just so far ahead of the pack that you have people that very quickly get ahead and then they are just smarter and then they can keep getting ahead and ahead and ahead. Like, yes, there will be advantages that people get from having these devices, but I don't expect it to be super rapid development until like until after anyone who wants one can economically get one anyway.
Right.
Like, yes, there are always going to be better ones, but I think it will be like the iPhone situation where in 2007, like, it was a big step ahead, but it wasn't like you were just leaving people with Blackberries in the dust, right?
Right.
And now, there are a lot of access to smartphones that, again, maybe some aren't as good as the top of the line smartphones, but it can get 80% of the way there, and that's probably enough to keep it from having huge issues.
So yeah, this whole enhancement discussion sort of leads into what we were talking about earlier with inequity, inequality between peoples, and we just think it's important to bring up now because you know it's definitely being shown as possible to enhance human cognition with these devices. Um, we just got to make sure that when those enhancements are widely available, everyone has access to it, and everyone is able to, gain the benefits from it that a small few will be able to. Um, so that's sort of the end of our discussion for today. Um, in the future, we're going to have some people on the podcast. We're going to be interviewing some people in the field, like I mentioned earlier. We're really excited for this to be sort of a place for us to just sort of spiel, just talk, and discuss some of our ideas. We do this already on a near daily basis, so it's nice to sort of capture that and have it stored somewhere, and that's sort of the whole purpose of this podcast.
Yeah, absolutely. I mean, we want all of you who are interested to be able to kind of understand our views in a way that's unscripted, and just get a window into that. And then the other end of that is we want to do that so that we can hear your views as well. We hope that people will contact us at the BCI Guys at gmail.com, or on social media, and you can give us your feedback and be like, yeah, I really agree with you on this point, or you guys are really dumb and this is how it should be, because it's the internet and there'll probably be stronger language than that, but we love it, and we want to hear people's thoughts. And so on that note, because we've been talking about human enhancement and all of these things, one question that I want to leave us with that maybe people can think about is, like, what would it take for you to get a brain implant? And then the other question is, like, what would it take for you to wear a headset every day? Because there are tons of EEG devices out there, but they don't provide enough value for us to wear it, to the grocery store and all that stuff. And, a brain implant doesn't make sense for us right now. So what would be the thing that would push you to get one? So think about that, and maybe we'll start the next podcast giving our own answers to that, Colin.
Well, thanks, guys, for listening to the first episode of the Brain Stream. If you have any ideas for future topics you'd like us to cover, or anybody that you'd like us to interview, you can add that to. We're going to be posting this on YouTube, so you can add that to the comment section on YouTube. We also have links in the description to our Patreon as well as our merch store. So if you're interested in supporting us in our content creation, you are welcome to do so there. We'd appreciate it. We like to feed our video editor Mike, because he's been very, very good to us. And yeah, I think that's it for the first episode of the Brainstream. Thank you guys for joining us. Anything you want to say, Harrison, before we close out here?
BCI Guys out. That's all. I'm
Thanks,
sorry.
guys.
I'd like to apologize.
Well, we'll see you next time.
That's the last thing. I would just like to apologize, and I will end every podcast episode
by apologizing.
I'm sorry you were here. Bye.